Okay, I just want to talk through the unit circle here and what we discovered today in class and started to look at with trigonometry. Okay, so if we just pick it up from the point at which we left it in class, and that was, as you see on the screen here, we have a right angle triangle is created here by this radius that extends from the origin out to the point A. Now A is a point on the unit circle that's just floating around. Currently it's locked in at 60 degrees or just above, and we've got here we've got the right angle, and then what we looked at right at the end of the lesson was, okay, our knowledge of Socotar, we know that sine 60 is equal to this length here, opposite over hypotenuse. Opposite over hypotenuse. Hypotenuse is 1, so therefore sine 60 is just equal to this side. So the length of that side there is sine 60. So that is sine 60. And that's acknowledged there. And then same principle, so cos 60 is the adjacent side, which is this length here, over 1. Over 1, obviously, that means that sine 60 is equal to this length here. So the length from there to there is cos 60. Sorry, did I say sine 60? I meant cos 60. So that means that if this is cos 60 and that's sine 60, then the coordinates of the point A, which in terms of their xy numerical values are here, 0.49, 0.87. We could look at them what's called, these are called the, we're going to introduce some terminology here. These are the Cartesian coordinates, which basically just mean the xy coordinates, the numerical value of x and y. And here we have what are called the polar coordinates. They're called polar coordinates because they refer to the angle. So polar coordinates, polar geometry is all based around angles rather than lengths. So they're polar coordinates, cos 60, sine 60, and what we should find is that they are that cos 60 is equal to, actually cos 60 is equal to 0.5, so this is slightly out because this is not exactly 60, and sine 60 I think we found was equal to 0.87 to 2 decimal places, so you can check that. But as A moves around the circle, obviously these values change, the angle changes, but what we'll notice wherever we go is that the angle that we create here, if we take sine 60 of it, we'll get the y coordinate. If we take whatever the angle is here, I said 60 again there, I didn't mean to. So if we changed it and we put that angle out to there, actually I might do that. Can I flip into this mode here? If I change this to, you can see that the angles there are changing. So let's just say I go up to 66, take it up to say 80. It's pretty close. 80.18, I'll try and get a bit closer. 80.27, 80.3, 78.69. Okay, I'm trying to get it close to 80, I'm not really sure why. But if I get it there, then yeah, the control with the pointer there is not great. If I use my arrows, it's even worse. So I'm just trying to edge across to 80 degrees. So it's 80.76, that'll do. So at 80.76, that's the angle there made with the x-axis in here, and the x-coordinate is 0.16. Now that should correlate to cos of 80.76 degrees, and I'd encourage you to check that with your calculators. Cos 80.76, you'll get 0.16. Put sine of that angle there, 80.76, and you should get 0.99. Do another check. I'll just give you another angle. Let's go right back here to about 20 degrees. 20.3, that's close enough. So we've got 20.3 degrees here now. So take the cos of 20.3, you should find that that's 0.94. Take sine of 20.3. Remember, cos 20.3, sine 20.3 are the polar coordinates for A. Then you should get 0.35. So just checking a few of those values. That's all in the first quadrant. what happens in the second quadrant? As you go across, let's have a little look. What happens is that the x-coordinate turns negative, obviously, and the y-coordinate turns positive, stays positive. And we can do a little check again. If you put into your calculators, we're at 143.87. Check that the cos of 143.87 is in fact minus 0.81. And if you do also check while you're at it, the sine of 143.87 should be 0.59. Okay, let's go back to the notebook. What I want to look at now, and the reason I've drawn these horizontal lines, is if let's have a look at the y-coordinate here, which is sine 60, or sine 60.67, not sure what that says, but we have the same y-coordinate over here. That's why the horizontal line there at point C. So the y-coordinate at point C will be exactly the same as at point A. So what is the polar coordinates of the point C? What are the polar coordinates of point C? So that means, well, what's this angle here equal to? So if that's 60, and this line here, this radius is just a reflection of this radius in the y-axis. So that will mean that this angle in here is held at 60. If we're calling this one 60, then that's also 60. So what is this angle in here? So if you have a little look at that, this angle is going to be 180 minus 60. So we should get polar coordinates in here of cos 120, sine 120. And so what we should be finding here is that sine 120 and sine 60 have the same value. And diagrammatically you can see that that must be the case given the symmetrical nature of reflecting this radii in the y-axis. We have to get the same, and I've done the same down here. I've reflected down straight down here to this point, which has it's just a double dash. So that's just a reflective sort of notation. So if we think about that, that's a vertical line there. So what are the polar coordinates going to be at that point? Try and think of that. So what you've got to do is work out the angle. All the angles are measured counterclockwise with positive x. So that's 120. What's this angle here going to be? It's going to get very busy on this. What's this one going to be? So if this is reflected in there, reflected in here, this angle is 60 in here. So we've now got a 180 plus 60. We've got 240 degrees. So the polar coordinates are cos 240, sine 240. And I'm going to leave you to think about what the polar coordinates of this point here are. If we let's just find out what the polar coordinates of that point there are. And from what we're doing here, we're going to establish that there's a relationship between all these angles and the angle that's made in the first quadrant, because we've got this symmetric property. So I'm going to leave the YouTube at that point. I'd like you to come up with the polar coordinates, please, for that point there in the fourth quadrant, and then we'll pick up on this theme in tomorrow's lesson and take it further. Okay, have a good night. I'll see you tomorrow.